Our speaker is Donna Kacmar, as I said, and she is an associate professor in the Hines College of Architecture, which we're currently in. She's also the author of Little Big House, Small Houses Designed by Architects. And she also is the director of the Materials Research Collaborative. I know some of you had a chance to take a tour of that facility, and that will be mostly the focus of her presentation. But before we get into the meat of materials and sustainability, I wanted to ask her the question of, if you had no limits, what sustainability initiative would you incorporate on campus? Which is a question we ask all of our speakers. And with that, Donna.
Great, thanks. When you asked me this question, I gave Sarah the answer, which is something I suggested maybe 10 years ago to the provost, which is having, this is my name for it, cougar bikes, like cougar bites, but cougar bikes. And they'd all be red, and we could have them all over campus, and they would be free for all of us to use, and they'd be paid for by local businesses. And graduate students would have internships to maintain them and move them around. Don't you guys think that would be great fun? So that's mine. Great. Well, thanks for having me here. Thanks for all of you coming. The Materials Research Collaborative is what I'm going to talk about today. We call it the MRC. It's open Monday through Friday, 1 to 5. It looks like this currently. We have materials along this edge. There's computers. The projector's a little bit out of skew, so it's a little bit washing out some of the slides. We have videos that we have every day on materials or material production. And then we have these meditation spaces that are kind of temporary, but were designed and built last spring by my students. So mainly we have a collection. It's a physical collection of materials and a database. And we have about 600 materials in our shelves. The shelves sit behind these doors. And so you can go in there and look for materials by their texture, their smell, their color. And you can't read this, but these are all of the material qualities that we look for, and we put it on our website. And you can get to our website by going to the College of Architecture website, going to the Materials Research Collaborative, and then this is our page. And there's a link to our database, a link to local materials, a link to Made in Houston and Reuse in Houston, and I'll be talking about these a little bit more. So this is what, if you go to our database of our materials, it looks like. It's organized by metals, polymers, ceramics, naturals, and hybrids. And you can click through this database by going to the website, but you can also, each material has a label on it that has a QR code, which will take you here. And so it lists the general description. You can click down here, and it lists the physical properties, but also the manufacturers, a link to their website. So if you click on physical properties, it tells you the sizes it comes in. And again, if you zoom in on the materials, they each have a QR code, which will take you to that website on your smartphone, which is really handy and very portable. So again, those samples are located along this edge. And in order to have this facility and have those materials, that's not what I'm going to talk about. I'm going to talk about this. I'm going to talk about these little meditation spaces that are in there currently. Each of them are meditation spaces that deal with a particular scent or sense. So this is smell. There's one that deals with sound, one that deals with texture, and this is a study they did of meditation. And this is how you're supposed to sit in that space. And then one that deals with light. So you can go in there, and there's more than materials right now. When we started this, we thought about what are the material information that students need to know or that designers need to know. And this is a drawing of production of ceramics, both in the world, in the U.S., and distributors locally in Texas. I know you can't see this, but this is the manufacturing process of different types of ceramic materials, and then where they're used in buildings. So this is kind of the range of the things that we want to know about materials. There's also things that are more sustainable aspects of materials. Things like the R value of a material, how much does it allow thermal movement from one side to the other of the material. or how insulative is it? VOC, what are the volatile organic compounds in the material? So is it, does it have any off-gassing, like paint often has a smell, and that smell is volatile organic compounds. It's also the thing that gives you the new car smell. It smells nice, but it's really not good for you. We also want to know, when we're interested in sustainable aspects of materials, the origin of the raw materials. Where in the world did we take that raw ingredient out of the earth? And what is the manufacturing process? Not just what is it, but how much energy does it use? Does it pollute the air? Does it harm the workers who are making it for us? How much energy is used in manufacturing? And we call that the cradle to gate. Cradle meaning the earth, and gate meaning the gate of the factory. So we think of the amount of energy used in manufacturing. It's usually expressed here as megajoules per kilogram or BTU per ton. So how much energy per weight of that material is used. And for example, we can look at titanium. And titanium uses a lot more megajoules per kilogram than cypress would. So if you put as cladding titanium rather than cypress, you're using a lot more energy just in the processing of that material. There's also embodied water, so how much water is used to manufacture that material. And carbon, how much carbon is emitted during that manufacturing process. There's this acronym called ICE, which stands for the Inventory of Carbon and Energy, and this is done by the University of Bath, and they have come up with these summary tables that deal with the amount of energy and the amount of carbon emitted during manufacturing. And it looks like this, and I know you can't read it, so we can zoom in and we can look at plywood and look at the amount of embodied energy and the amount of embodied carbon for plywood, and we can compare that to hardwood or veneer particle board or our titanium examples. And so this is a really good resource for understanding the amount of either embodied energy or embodied carbon in various building materials. So, as I mentioned, we think of cradle to gate, so coming out of the earth, going to the gate of the factory. Then we have to get that material from the gate of the factory to our building site. And you can think about it, how much energy or water or carbon is in play during this whole process. So energy used in transportation is not just a function of how far it's going, but it's how is it being transported. So if we can put something on a boat, that's a lot more efficient in energy use than if we put it on a plane. Of course, we don't put most building materials on a plane, but we do put most things on a truck now. And that is more than 10 times less efficient than putting it on a train. And we don't put things on trains and use rail transport as much anymore because we're so interested in time and getting things to us quickly. And it's, just more cumbersome to use a rail system than a truck. But it certainly uses